Hi, my name is Camila Hernandez, and this is my final presentation of the key activity. We have first a research problem, which is determine the aerodynamic of the object in relation with the shape of the mass that a catapult is transporting. So for this experiment or for this project, we did a wooden catapult, and we have 5 different projectiles to determine the rate of aerodynamics. That's why we have the hypothesis that states that there should exist a change in the velocity and aerodynamics of each shape, with some questions that you could say they are actually the goals or objectives of this experiment, which are: how does changing the shape affect the result of the motion? What is the best shape to create a more precise impact? And which shape does the catapult have a better airflow? All of this is to have a better outcome in between aerodynamics. A bit of the justification is that this project not only makes us research, but it allows us to create an experiment to prove our hypothesis by using, in this case, parabolic motion or CPM to determine distance, velocity, and acceleration. Now, a bit of an introduction is that we used a wooden catapult made with lollipop sticks, rubber bands, and a water bottle cap. And then we have 5 different shapes of clay projectiles with the same mass. All of this to prove different outcomes and rates of velocity so we can get the aerodynamics. That's why we have 3 different variables, which are independent, dependent, and control variables. For the independent, we have the shape of the clay projectile because they share the same mass, which is of 4 grams. This way we can determine how the geometric shape affects the outcome of the dependent variables, which are the velocity, and in this case, their change in aerodynamics. That's why we also have the control variables, which is the weight of the projectile, which is 4 grams, the material of the projectile, which is model in clay, the launching mechanism, which is the same for every single one of the projectiles. They all have the same force applied, and the environmental conditions, because this experiment is being held in a closed space, that this way the airflow does not interfere in the launch. Now, for the experiment, as I said before, every projectile was placed on a catapult one at a time, launched from the same place with the same force. Uh, well, we tracked time and distance. Also, we recorded because we needed to take the vertical shot and the free fall specific times. Now, for the shapes, we use a sphere, a heart, a triangle, a drop, and a rectangle. Now, for results and data collection, I did 2 data sheets and a spread hand sheet with procedures. For the first data sheet in my left side, we have times and distance. We can see that the full time is probably not that far from each other, and that the distance is the one that you can see a big difference. And we have the vertical shot time and the free fall time because we have 2 different motions. Now for the other data sheet, we have the final velocity of the vertical shot, the free fall, initial velocity, and the average velocity, when we can tell a bit more of the difference. Now in the bottom, we have a picture of the scale with weight and the picture of the procedures. For data analysis, we confirmed the hypothesis, and we also confirmed that the drop was the best shape and it had the most precise impact. Also, that the rectangle did the less distance and it did the most time. Also, we have that the shape actually influences in the velocity and the distance. As a brief conclusion, the experiment answers all of the questions and proves the hypothesis, also represents that we can use physics for everything and that shapes actually interfere in the aerodynamics or in the airflow. A bit of a limitation was that the catapult would have worked better if it was made at a bigger scale, but as I made it, I don't think that was that much of a limitation. Now, the scientific method was really important because it keeps a better flow while doing the experiment, but it's also important to have order so we don't mess up the experiment. That's why it also allows us to get a better result. Now, finally, we learned that physics is everywhere. The use of friction in the air is really important, and how we mix motions with concepts like CPM and friction. Now, that was everything, and thank you so much.